So now we're gonna discuss the fourth problem from day 6, that is a palindromic linked list. So we are given the head of the singly linked list when we have to return if the linked list is the palindrome. So what is the palindrome? Palindrome is something if it is traversed from forward or from backward, it remains the same. Such as for the string madam, if we traverse it in the forward direction, it will remain MADAM as madam, and if we traverse it from the reverse, it will again remains as madam, MADAM. Okay, the same is here. If we traverse the linked list from the front, that is this 1 2 2 1, and if we traversed it from the backward 2 1 2 2 1, it remains the same. So this is a parent. So how we gonna discuss, how we gonna approach this question? There are multiple approaches to solve this question. First, I'll solve this uh, using a naive approach, and then we optimize that naive. So how will we approach this? So how will we try to approach this question? We can use a stack. Simply use a stack, fill every node in the stack, and just pop one element from the stack and compare with the element in the linked list, then move, iterate over the linked list to the next node, then again pop one element from the stack, compare both the elements. If they are equal, until they are equal, the linked list remain as palindrome, and if we reach the end of the linked list, the whole linked list is a palindrome. So this is the naive approach. Let me just for try run for this test case. So we are given a linked list. We are given a linked list 1 2 2 1. We can see as it is a palindrome. So it will return true. Okay. So we'll maintain a stack. A stack is a data structure that is LIFO, last in, first out. Okay. It follows the principle of last in, first out. We push, we traverse the linked list, we push 1, then we push 2, then again we push 2, then again we push 1. Okay, so this is the complete stack. Now again our temporary pointer will be pointing to this node. Now this is this stack top. Okay, we're gonna compare if this element that is pointed by the temporary pointer is equals to the element present at the stack top. If they are equal, we move our temporary pointer to the next node of the linked list. We pop one element from the linked list. Now our stack top will become this element. Now again we compare these two. If these two are equal, our temporary pointer will point to the next node in the linked list, and in this stack gonna pop the top of the stack, and our new top of the stack will become this. Now we again compare the node pointed by the temporary pointers and the value stored on the stack top. If they both are equal, we move the temporary pointer to the next node, and we pop the stack top, and now our updated stack top will be this. Again we compare, if these two are equal, I'm gonna delete this node and move our temporary pointer to the next. We're gonna check until our temporary pointer will be pointing to null. Okay, this has reached null. We can return true as our linked list is coming. Okay, so this is the naive approach that takes a time complexity because we have traversed the linked list twice. Two, so what is the time complexity? Order of 2n. That is basically order of n, and space complexity of order of n because we are maintaining a stack. Okay, so this is the naive approach. So what is the optimized approach to solve this problem? Okay, so what we'll do, we have solved the question that is that using which we can find the mid of the linked list. So if you have forgotten the approach to find the middle of the linked list, what we have done in this question, we have maintained two pointers, that is the slow and the fast pointer. The starting these will be pointing to the head of the linked list. Fast pointer will move two step, fast pointer move two step, and at the next iteration it will be pointing to this, and the slow pointer will be pointing to this. The next iteration, slow will be pointing, fast will be pointing to null. We'll we will run this loop until the fast will be pointing to last node or will be pointing to null, or the we can say the end of the loop. So a slow will be pointing to this. Okay, so this is the middle. Okay, this is the middle. So we divide it from the middle. So this becomes one linked list. This becomes second linked list. We're gonna reverse this second linked list. We're gonna reverse it now. Our linked list will become this. This is sublinked list 1. This is the sublinked list 2. We have reversed this sublinked list, and this will become 1, 2. Then we're gonna compare sublinked list 1 and sublinked list 2 using the temporary pointers C1, C2, and traverse whole linked list until we reach null, until we reach null, until our temporary pointer will be pointing to null. And if these are pointing to null or we have reached the end, we can say that if the values of the nodes does not mismatch, we can say that this linked list is a palindrome and will return. So we'll discuss the code for the optimized approach, and this optimized approach, I forgot the time complexity. This will take an order of n time complexity, but a space complexity of order of, so we are reducing space. Okay, because we have to traverse the whole link. Okay, so now we're gonna discuss the code for the optimized approach, because the naive approach is very intuitive. It will be very easy for you to code this. So I will be coding this one, but I will give you the link for the code for this one approach also. Okay, so now we'll look at the code. So let me discuss the code with you. So this is the given function is palindrome that returns a boolean type, and we have just received the head of the linked list as a parameter. So if if there is no node in the linked list, we're going to return false. Okay, so if there is one node in the linked list, what we want to say, one node itself is a palindrome, so we'll return true. And if these two cases do not match, we're going to find the middle the linked list. So this is the approach. So this is the function that we'll use to find the middle of the linked list. We have maintained two pointers, the slow pointers and the fast pointer. Initially, they both are pointing to the head of the linked list. Then we're gonna use a while loop to iterate over the linked list, and we'll make the slow pointer jumps one step and the fast pointer jumps two steps, and we'll run this loop until our fast pointer will be pointing to the end of the linked list or to the null. Okay, or Null means that it will be pointing to the end of the linked list. Okay, and we'll return the slow pointer, that is the pointer that is lagging behind. It will be pointing to the middle of the linked list. And if we have find the middle of the linked list, we have used the add first method, because what we have discussed in the approach, we're gonna reverse sub linked list. This is the sub linked list 2 we have find using the middle, because from the middle to the end of the linked list it is the sub list 2. We're gonna reverse the sub list 2 using the add first method. I have previously discussed this add first method. I just run over the code. We can use our temporary head and temporary tail pointers, and our temporary pointer that will be pointing to the next node. Okay, and we're gonna add the nodes at the front of the linked list, traversing the linked list and adding the nodes at the front of the linked list, and returning the head, temporary head formed for the linked list. Okay, now the temporary pointer C2 will point to the temporary head or the head of sublist 1, and C1 will be pointing to the head of sublist 2. Then we're going to traverse the both the linked list, sublinked list 1 and sublist 2, until our value pointed by the temporary pointers mismatched. If these values mismatched, we're going to return false. If they do not mismatch, we're going to return, because this loop will will terminate without any exception. Okay, will return true. Okay, so this is the code for the question palindrome linked list. So if you have any doubt, please feel free to ask in the comments. Okay, the link to the code is given in the description. Please check it out. Okay.